For section 10.6, I'll take a look at 4 problems for parametric equations. First 2 problems, they're going to ask you to eliminate the parameter and then sketch the curve. So eliminate the parameter means get rid of the t, write it in rectangular form we call it, or y equals something with x in it, and then we'll sketch the curve of it. May have to pay attention to restrictions, and I can see there's a restriction here, so that one will have a restriction. Here we're going to eliminate the parameter and sketch the curve of something with theta in. Third question we'll take a look at is they're going to ask you to write a set of parametric equations for an ellipse that has the vertices and foci of those 2 sets of points. And then the last one's going to ask you to find the maximum height of a projectile launched at an initial upward velocity of 60 feet per second at an angle of 30 degrees, modeled by the parametric equations, and then there are your parametric equations. And then it's also going to ask you to find the range of the projectile. So this is kind of like number 57, I believe it is, on your homework. Alright, so back to the first one. It's going to ask you to eliminate the parameter and sketch the curve. So eliminating the parameter meaning get rid of t. So how we usually did that is we said, well, let's take the x equal equation and solve it for t. So I'll do that. If I want to solve for t, I'm going to have to square both sides, so t is equal to x squared. And then once I have that, I will take that and plug it in for t in the y equal equation. So I will now have y is equal to 1 minus t, or 1 minus x squared. And there it is in rectangular form, or there we've eliminated the parameter. Now we're going to draw a sketch of basically this with a possible restriction if we notice one. Alright, so I know that this is a parabola. It's opening down. It has a vertex point at 1, 0 because it's in vertex form. So it looks something like this without me drawing the whole thing in completely. The problem I have, or not necessarily a problem, but the thing I need to catch up here is that there's a restriction on t. T can be anything I want it to be here, but I can't have a negative value here. It has to be either equal to 0 or greater than 0. So think about it. If I plug a number in that's 0 or larger, I can never have a negative x number or value. Meaning when I look at this parabola, this part shouldn't exist. This is actually the graph that I'm going to have, is just that. This part won't actually exist because of the restriction on t. Now to determine direction, which I don't have written in here but they'll ask you to do, either this parabola is going to the right and then down, or it's going to the left and up. And to determine that, what I would suggest you do is go back to the 2 original equations, pick 2 numbers for t that actually make sense, so don't pick like -5, and plug them in and see what you get. You can pick whatever numbers you want for t, so I'm going to pick 0, and then I'm going to pick 4. I would pick numbers that are going to make it easy on you. That's why I picked 4. Don't pick 2 because then you have to deal with a radical, but anything will work. Doesn't matter what numbers you pick. Whichever t number is the smallest, that point that you end up with is where you're going to start. So when I plug in 0 to the x equal equation, I would get the square root of 0, so the x value is 0. Plug in 0 here for t, y would equal 1. So 0, 1, this is kind of my starting point. And now I'm going to go whatever direction this point tells me to. So now, and that's because it's a bigger number than this. So now I'll plug in 4 here, that gives you 2 for an x value. Plug in 4 here, it gives you -3. If I plotted the point 1, 2, 1, 2, 3, it's right here. I'm going to go from my starting point to the other point, so I'm going that direction. Now I didn't have to pick 0, let's say I actually picked 1 instead. Had I picked 1, my x value would have been 1, my y value would have been 0. So 1, 0 is right here because this is the smaller t amount. That means I would be starting at that point. And I would go to that point, and I'm still going that direction. So it doesn't matter what numbers you pick for t. Whichever the smallest number is, that's the point that you start at. So I'm going kind of down and to the right that way. Alright, the next example, eliminate the parameter and sketch the curve of, okay, when I see I have a trig function, I have to use one of the 2 formulas that we had on the notes. And when it's cosine and sine, this is what I want to use. I want to use that the cosine squared theta plus sine squared of theta is equal to 1, identity. So what I need to do for both of these is get sine and cosine by themselves. So if I look at this one, to get cosine by itself, I would have to subtract 4 and divide by 2. So I would say that the cosine of theta is going to equal x, have to subtract 4, have to divide by 2. Over here, if I do the same thing, try to get the sine by itself, I would have to subtract 2 and then divide by 3. And so now I've got cosine by itself, I've got sine by itself. I want to make a substitution. I wanted to be able to take this and just substitute it in here, but I need this to be cosine squared, so I'm just going to go ahead and square both sides. And that would give me cosine squared of theta is equal to, don't actually multiply that out, leave it as x minus 4 quantity squared over 2 squared, or 4. If you think about it, this is going to replace that. Something that looks like this plus something that looks like this equals 1. It's an ellipse or a circle or something like that. So I want it to kind of look like this. The sine, same thing. I want to square both sides so that I can just make a substitution. And I will have sine squared of theta is equal to the quantity of y minus 2 squared over 9. And now when I make my substitution, instead of saying cosine squared, I'll just say this. So it's going to be x minus 4 quantity squared over 4 plus sine squared, which is really y minus 2 quantity squared over 9 equals 1. And there it is. I've eliminated the parameter of theta. And now to graph that, go ahead and give yourself some tick marks here. Alright, it's just an ellipse, so the center looks like it's at 4, 2, so 1, 2, 3, 4, 1, 2, there's the center. The denominator under x is 4, so take the square root, I would move 2 to the right, put a point, 2 to the left, put a point. Denominator underneath y is 9, take the square root, I would go down 1, 2, 3, and up 1, 2, 3, and then there is my oval shape. And this isn't always going to be true, but for any problem that we do, if you have to draw anything that's an oval or a circle, you can, without showing the direction, you can just say that I know it's going to go counterclockwise without showing anything, and I would be fine with that. Alright, so anytime you're going to eliminate the parameter and you see sine and cosine in the formulas, that's the identity that you would want to use. If you see tangent and secant, then you're going to use a different formula, and you can find that one in your notes. Alright, the last one on the front side before we do the back side is find a set of parametric equations for an ellipse with vertices 4, 7, 4, negative 3, and foci 4, 5, 4, negative 1. What they are asking you to do, they're asking you for parametric equations. They're actually looking for answers like this. So what we're doing for this problem is we're working backwards. I need to, with this information, come up with this equation and then basically work backwards to get to here. So first thing I need to do, come up with the actual equation for this ellipse. So the vertices, remember when you're trying to do this from section 4, or I guess it would be section 3 for an ellipse, first thing you want to do is find the center. So the center or the midpoint, and you could do it with either one of these two, is going to be 4 since the x value didn't change. Add those together, I get 4, divide by 2, it's 2. So the center is 4, 2, so in terms of writing my formula in standard form, it's going to be x minus 4 quantity squared over something plus y minus 2 quantity squared over something equals 1. Alright, the other thing I get is if I look at the y value, I can see that it's a distance of 5, so a is 5. It's y that's changing, so when I square 5, I end up with 25, and that should go under y. Alright, so I got almost everything except for b squared over here, and that's where the foci come in. If you look at the distance from the foci to the center, it's 3. So that means c is equal to 3. And so now I'm going to use the equation c squared is equal to a squared minus b squared because it's an ellipse. And c squared would be 9 is equal to a squared, which is 25, minus b squared. Subtract, I get negative 16 is equal to negative b squared, or b squared is equal to 16. And so here is my formula for the ellipse in standard form. Now think about what I did here for this problem, and basically let's work backwards. Here I've got this. I need to work backwards. I'm going to set the term that's got x on it equal to the cosine. The term that's got y on it equal to the sine, and then I'm going to try to solve for x or y. So I'm going to take this term, x minus 4 quantity squared over 16, and I'm going to set that equal to cosine squared, because in this identity, it's taking its place. So again, making that substitution. And now I'm going to solve for x, because parametric equation should say x is equal to, and then something with theta in it. So, solve for x, I would want to take the square root of both sides, or I could multiply by 16, then take the square root, doesn't matter when, but that's going to give me x minus 4 over 4 is equal to the cosine of theta. Going to multiply by 4 and then add 4. So I would get 4 plus 4 cosine theta. There's the x part of my parametric equation. Now I need to do the y part of my parametric equation. And so same idea. Take the second term, the y minus 2 quantity squared over 25. Set it equal to sine squared theta. You can either multiply by 25 or take the square root of both sides first. I'll do the square root first. That's going to give me y minus 2 over 5 is equal to sine of theta. And then think about what you'd have to do. You'd have to multiply by 5 and add 2. So y would equal 2 plus 5 times sine of theta. And there are your parametric equations. Try to, if you can, go back and look at these two examples and see how similar they are. They're asking you to do the complete opposite. This one, they give you the parametric equations, you get it in standard form. Here you got it in standard form, you get it into parametric equations, and you'll see that hopefully that'll help. All right, the last one, this is kind of like 57 from your homework. It's going to ask you to find the maximum height and the range of a projectile that's shot at an initial upward velocity of 60 feet per second at an angle of 30 degrees. And they were nice enough to give you the parametric equations so you didn't have to memorize them. I would say you probably want to have those memorized. All right, so the x substitution is going to be x is equal to, or I guess not substitution, but equation. It's v sub 0, which they told us was 60 feet per second, times the cosine of 30 degrees, which is the square root of 3 over 2, times t. So I can say that this is square root of 3 over 2, or that would simplify to 30 square roots of 3t. Now at some point in time, I'm probably going to want a decimal for this, so if you want to change that to a decimal, you can, but for now I'm just going to leave it. My y equation, or parametric equation, is the height, which they don't mention anything about the height, so I have to assume it's 0, plus v sub 0, which is 60, times the sine of the angle, which is 30, which is 1/2, times t minus 16t squared. Alright, so 1/2 of 60 should give me 30, so my equation for the y equal equation is y is equal to 30, I'm going to put the squared term first, negative 16t squared plus 30t. Alright, so there are my parametric equations, and now what I'm going to do is I'm going to write it in standard form, or I'm going to eliminate the parameter. So remember what we did is we usually took the x equal equation and we solved it for t. So that would mean that t is going to equal 1 divided by 30 square roots of 3x, right? Well, I'm going to figure out what that is as a decimal. So let's go ahead and figure out, if you didn't already, 30 square roots of 3, that's that number. I'm dividing by that number, so it's 1 divided by that previous answer. That's the decimal that's sitting in front of x. So t is going to equal approximately 0.01925x. So there's what t is equal to as an exact number. Now I'm going to take that and plug it in for t in both of those t's. And that should eliminate my parameter. So I'm going to need my calculator handy. So that's going to give me y is equal to negative 16 times 0.01925x squared plus 30 times 0.01925x. And so with your calculator, you can take 0.01925, or you could just use the actual number, and square it. Since these are being multiplied, I can square them both separately. Have to multiply that number by negative 16. And it looks like my equation is going to be y is equal to negative 0.005929 x squared plus, now take 0.0125 times 30, and I should get plus something, didn't look right here. Oh, I piped the wrong number in, sorry. It's 0.01925 times 30. There we go. 0.5775. And here's my equation now in standard form. Alright, so the two things I'm looking for now. let's think about it before we actually go to the calculator and do it. I could do it by hand, but the calculator would be much quicker. This is a parabola that's opening down. They both have x, they both have x in common, so I could factor it out. I'm looking at a parabola that looks something like that. So when they ask me to find the maximum, they're looking for, of course, the vertex point, which means if I wanted to find it, I could really do x is equal to negative b over 2a, take that number and plug it in for x, and that would give me my answer. Obviously, with the decimals, wouldn't be nice, but if you're doing this problem, you're going to be using a calculator anyway. The other thing they're asking for is the range. Now, the height we said was 0 because they didn't tell us about the height. So the range would be, if I launched it here, how far does it go before it hits the ground? What is that distance? And so basically, I'm looking for the x-intercepts. I know this one's 0, 0. I just need to know what that one is. And then whatever that x-intercept is, that's the distance, since the x value here is 0. So that's what we're looking for. Now I'm going to use my calculator to graph it out and do it. So go to y is equal to, type in your function, negative 0.005929 x squared plus 0.5775x, and hit enter. Go ahead and hit the graph. And because this graph probably is not going to fit on your calculator just because the numbers aren't so nice, you can a lot of times go to zoom and then number 0 is zoom fit. So zoom and then 0, a lot of times that gives you a better picture. It's not going to this time, which is fine. So what I'm going to do is I'm just going to play around with my window. I can see that it's curving somewhere over here, or I can tell just by kind of algebraically doing it that it's going to curve somewhere over here. So I'm going to go to window, my x minimum, which is, you know, the numbers over here right now is at negative 10. I could probably go to 0 because I know where that's going to be. I'm going to hit negative 2 just to say somewhere to the left of it. Hit enter. X max, it's probably over to the right somewhere. I'm going to guess, let's say 200. Hit enter and then graph it. And basically see, do you see the function come down? Yep, I do. So I'm far enough to the right. If you want to readjust it, you can. You can say 100 or 120 or 50 or whatever it is, but that's good enough. Now I can see that it goes up, and I need to go above it. I don't really need to go below the y-axis, so when I go back to window, on the y minimum, I'm really just going to say negative 2 just to stay below it a little bit. And then the y max, again, you're basically taking a guess. I'm going to hit 60 and hit enter, and that was enough to see it. I'm going to go back to the window and say, let's go maybe 20, just to get a little bit better picture. Okay, there we go. As long as you can see the curve and the actual hump on the top, that's all you really need to see. Now, we're looking for, remember, the vertex point. So remember how to do that with your calculator. You're going to go to second calc, and you're going to pick, it happens to be a maximum. And then it asks you for the left bound, so just make sure you're somewhere to the left of that maximum point. So scroll over till you get there. Hit enter, go somewhere to the right, hit enter, and then you should be able to just hit enter again, or I always go back one tick mark. And we're looking for the y value. The y value is 14, so I have a max height of 14.0625 feet. And now if I want the range, I need to know what that x-intercept is. I technically need to know both, but I know this one's 0 because they have x in common. So go back to second calc. This time pick 0 or number 2, and now somewhere to the left of it, so we're definitely on the left of it, hit enter. Somewhere to the right, hit enter, and you can pay attention to the y value. I'm below it, so I know I'm to the right. Go back one, hit enter, and it tells me that the x value is 97 point, let's just say 4 feet. Now because I know this one's 0, I don't have to subtract them, it's just going to be this. So this is my range. Alright, that is homework help for section 10.6. Let me know if you need extra help.